Good day, everyone. We are here to present to you our Arduino project. First of all, I would like you to introduce to you our group, Group 5 with the group name Broco. Together with my members. Next slide. Mark Allen Hortilano, Daniel Monteroso, RB Lavitat, Maria Risa Mejia, and Nikki Zane Canzon.
The Project 11. Interact with servo. This Arduino code demonstrates how to control a servo motor using a potentiometer. The potentiometer acts as a variable resistor, allow the user to adjust the resistance and in turn change the voltage read by the Arduino. The voltage reading is the used to set a angle to a servo motor.
The materials we will be using are DIV Arduino Uno prototype shield with breadboard, 3 pieces jumper F to M, 3 pieces jumper M to M, 1 servo, and 1 10K potentiometer.
This is a little different from our previous project as we are using a potentiometer. Potentiometers are sometimes called variable resistors, and they are just that. By turning the knob, you are altering the electrical resistance of the component. It has 3 pins, 2 side by side and 1 on top. Connect the side by side pins to 5V and GND on the Arduino respectively, and the single pin on the opposite side of the potentiometer to the analog 0 pin on the Arduino.
And after that, you will see our group preparing for this project. And for the code, this code controls a servo motor, reads input from a potentiometer, and for the constant integer, we declare servo pin as an output 9 where the servo motor is connected. We also declare integer potentiometer pin is equal to AU since the analog input pin where the potentiometer is connected. We declare include servo library that provide function to control a servo motor, which will be used to control the servo motor. For the setup function, we declare pin put pin. We also declare my specific pin, allowing control of the servo. For the loop function, this function runs continuously after the setup. We declare in potentiometer value is equal to analog read that read the analog value from the potentiometer, which range from 0 to 1023. We also declare int servo angle maps the potentiometer value to range 0 to 360 degrees for the servo angle. Also, lastly, we also declare delay as 15 milliseconds allow to servo to reach the desired position before the next reading. After that, you will see the final output. And for the challenge, our challenge titled is Interact with Servo using and adding a buzzer. This Arduino code controls a servo motor, a potentiometer, and a buzzer in an interactive system that responds to user input through the potentiometer. The potentiometer adjusts the servo position, and when the servo reaches a specific position, it triggers an alarm using the buzzer.
So for this challenge, the materials we will be using are leaf Arduino Uno, prototype shield with breadboard, 3 pieces jumper F to M, 5 pieces jumper M to M, 1 servo, 1 10K potentiometer, and 1 buzzer.
This Arduino code controls a servo motor and a buzzer using input from a potentiometer. The potentiometer allows users to adjust the angle of the servo, and when the servo reaches a specific angle, 180 degrees, it triggers a sound pattern from the buzzer. Servo pin, digital pin to pin 9 connected to the servo motor. Potentiometer pin, analog pin to A0 connected to the potentiometer. Buzzer pin, digital pin to pin 8 connected to the buzzer. Symbol stores the calculated scene value for tone modulation. Tone valve holds the frequency of the tone to be played on the buzzer.
And for the code, this code controls a servo motor, reads input from a potentiometer, and activates a buzzer to create an alarm pattern when the servo reaches a specific angle. So it's almost the same with the activity number 11 but with the adding components buzzer. So for the input, we also declare integer pin 9 as a digital output for the servo motor. Also, we declare integer as a potentiometer pin is equal to AU0 that define the analog input for the potentiometer. We also declare buzzer pin is equal to 8 that defines pin 8 as a digital output for the buzzer. For the variable definition, we also declare float symbol that store the calculated sign value. We also declare int tone val to store the frequency of the tone to be generated by the buzzer. Also, we declare include a servo H, a servo library to control the servo motor. We also declare servo as an instance of the servo class named myServo. For the setup function, we declare pin mode output that initialize the servo pin as an output. We also declare myServo attach that attach the servo object to the specific pin. We also declare pin mode buzzer pin as an output to initialize the buzzer pin as an output. We set serial begin to 9600 to initialize the serial communication from 0 to 1023. Also, we declare servo angle is equal to maps the potentiometer value to a servo angle from the servo to the calculated angle. We print servo angle that prints the current servo angle to the serial monitor for debugging. We also declare if statement. If servo angle is equal to 180 degrees, if true, it creates an alarm pattern. A for loop iterates 360 times to generate a tone with varying frequency. We use synval is equal to syn is equal to I times pi over 180 that calculates the syn value for the current iteration. And for the tone, we declare 2000 plus SynVal times 1000 that calculates the frequency of the tone on the sine value. We also declare tone buzzer as an output that generates the tone of the buzzer pin based on the calculated frequency. And lastly, we also declare delay that introduce to control the speed of the alarm sound. And after that, you will see the final output. And that's all. Thank you.